Hello, and welcome to the next video in my series on basic statistics, and for this video, finite mathematics. The topic of this video is taught in both stats courses and finite math courses, so you may be watching this video in a stats playlist or in a finite math playlist, but either way, it applies to both. Now just a reminder, these videos are geared towards individuals who are relatively new to stats, or finite math for that matter. So I will just be covering the very basics, using step-by-step examples very deliberately. And finally, if you're watching this video because you're having trouble with a class, number one, I want you to stay positive. I want you to keep your head up. And then I want you to take a deep breath and realize that if you're watching this video, it's because you've come a long way. And with a little bit of help, a little bit of hard work and determination, we can get you through it. So hang in there and let's see if we can help. So all that being said, let's go ahead and get going. Now in this video, we're going to continue our discussion of basic counting principles. So in previous videos, I have talked a lot, very in depth, about combinations and permutations. So in the next few videos, I'm actually going to do some pretty standard example problems, ones that you will often see all around the world, or definitely in the United States, when you first encounter these topics in your classes. Now in this video, we're going to be talking about combinations, and more specifically, a common type of problem involving like marbles in a bag. And we're going to walk through some different scenarios where you reach into the bag or bucket of marbles and you make some choices. You make some selections. You might reach in and grab a certain number and then you see what you have. So we're going to be looking at this very standard, very common marble problem, but it does have 4 different questions built into it. So it won't be just a simple, one question problem and then we're done. So let's go ahead and get started. So here is our problem. We have a bucket containing the following marbles. We have 4 red, 3 blue, 4 green, and 3 yellow, for a total of 14 marbles. Now each marble is labeled with a number, so they can be distinguished. Now, a few things here before we continue. The numbers on the marbles are only there so you can tell them apart. I could have used symbols like stars and triangles and rectangles and whatever. And that would have made a difference. So don't think of the numbers as any order or anything like that. The numbers are just there so we can tell marbles of the same color apart. So you can see there we have our 4 red, we have our 3 blue, our 4 green, and our 3 yellow, for a total of 14 marbles. So here are our questions. Number 1, how many sets or groups of 4 marbles are possible? So if we reach in and pull out 4, how many possible groups of 4 can we have? Number 2, how many sets or groups of 4 are there such that each one is a different color? So we're going to have a red one, a blue one, a green one, and a yellow one. How many ways can we do that if we reach in and grab 4? 3. How many sets of 4 are there in which at least 2 are red? So 2 can be red, 3 can be red, and 4 can be red. At least 2 reds. And finally, how many sets of 4 are there in which none are red, but at least 1 is green? Now, of course, question 4 is where the students I work with start rolling their eyes back into their head, because they see this, how many sets of 4 are there in which none are red, but at least 1 is green? And I get the huffs and puffs and sighs and things like that. It's actually a fairly straightforward problem, but let me get a little commentary here. What can make these problems challenging? Because mathematically they're very simple, but it makes us think in a way we're not used to thinking. In the U.S. education system, at least, we are brought up to think in a very linear fashion. So we think from start to finish, left to right, beginning to end, and so forth. But these problems don't always fit that mold. Sometimes we have to think in a circular fashion or in a reverse fashion, and that can really trouble students that have AP Calculus in high school, but then come to finite math class in college and look at a problem where they're asked to count marbles and they're not sure how to do it. It can be very frustrating. So just remember, some of these are pretty straightforward, but it causes us to think in ways that we're not used to. That's what makes them challenging. Okay, so let's look at the first question. How many sets or groups of 4 marbles are possible? I want to stress something I stress with the students I work with. I want you to actually visualize in your mind, actually think of physically reaching into the bucket and grabbing 4 marbles. Okay? So we have this bucket of 14 marbles or a bag or whatever it is. You don't look, you reach in, you feel for 4 in there, and then you pull those 4 out. Okay? So we want to know how many sets or groups of 4 marbles are possible. And each group would be different. Okay? So in our hand we might have a blue marble. Well, that could be blue 1 or blue 3. Okay? That would be different. So how many different groups of 4? Think of actually doing the act of reaching in and grabbing the marbles. So for this answer, we're just figuring out how many ways we can choose a group of 4 different marbles out of the total of 14. And we say that as 14 choose 4. And we write that as C for combination and then 14, 4. And if you watched my previous videos, you'll see how we do this. But I'm going to assume you've watched those or you've seen this before. So there are 1,001 ways to reach into that bag and grab 4 different sets or a set of 4 different marbles. 1,001 different groups of 4. So keep that number in your mind. I picked that because it's almost 1,000, so it's easy to work with. So 1,001, almost 1,000. So that's our first question. It's pretty straightforward. Now, how many sets or groups of 4 are there such that each one is a different color? So we have to open up our hand, and it has to look like this. We have to have a blue, a yellow, a red, and a green. Now, the blue could be any one of the blues we have. The yellow could be any one of the yellows we have. The green could be any one of the greens we have. And of course, the red could be any one of the reds we have. So, if I have blue 1, yellow 1, green 1, and red 1, that's a group. But I could have blue 1, yellow 1, green 1, and red 2. That's a different group of 4 because we're using the red 2 marble. Okay? So, they just have to be 4 different colors. So how many choices do we have for the blue? Well, we have 3. How many choices do we have for the red marble? We have 4. How many choices do we have for the green marble? 4. And how many choices do we have for the yellow? And of course, that's 3. So we're only choosing one representative of each color. And of course, each color has multiple representatives in the bag. So there are 3 blues, 4 reds, etc. So how do we figure this out? Well, I went ahead and color-coded this so you can see exactly where the answer comes from. So look at the bottom there. We have 3 choose 1. And of course, if it's in blue. We have 3 marbles, and we have to choose 1 to represent blue. Times 4 red marbles, and we're choosing 1 to represent the red. 4 green, we're choosing 1 to represent the green, and 3 yellow, and we have 1 to represent the yellow. Now remember, we're reaching in and pulling these out at the same time. We're not pulling them one at a time. It's a group of 4 in our hand. But each color can have a different representative because there are multiple ones of each color in the bag. So this is just 3 times 4 times 4 times 3. And that equals 144. So, of the 1,001 total groups of 4 we could reach in and grab, 144 of those are going to be 4 marbles of a different color. And actually, in a later video, we're going to talk about probabilities. So we could think of the question is, if we have these marbles in the bag, what is the probability that we pull out 4 marbles that are all different color? And in terms of probability, it's 144 out of 1,001, which is about 14.4% or 0.144. Okay. Now the next one. How many sets of 4 are there in which at least 2 are red? So, in this case, we are interested in the outcomes that have 2, 3, or 4 red marbles. So at least 2. 2, 3, or 4 red. So what would that look like? Well, it would look like this. We could have 2 reds, and of course the black stand for not red. So 2 red, 2 not red. And of course the 2 not reds could be any of the other 3 colors. So that's 2 red. Or we could have 3. 3 red, 1 not red. Or all 4 are red. So if you look at our question, it says at least 2 red. So we can have 2 red, 3 red, or 4 red. And of course the other ones, in the case of 2 and 3, would be not red. So again, this is one of the ways that, you know, we don't necessarily think this way all the time. We think in a very straightforward linear fashion. So 2 red and 2 not red is a little bit different. I work with students all the time that would think, okay, I have 2 red, so the other 2 could be both blue, they could be both green, both yellow, 1 red, 1 green. See what I mean? You could do that way. That's more straightforward and linear. But this case, 2 red, 2 not, 3 red, 1 not, and 4. So here's our first one. Now, think of our total marbles in the bag. What do we got in there? So, the 2 red marbles could be 2 out of the 4 that are in the bag. So there are 2 red marbles, or 4 red marbles in the bag. We need 2 for this outcome. Now the other 2 could be from the other 10 marbles. Because remember, we have 4 red, so the remainder of the marbles in the bag are 10. So 2 out of 4 for the red, and 2 out of the remaining 10 for the 2 not red. So how do we figure that out? Well, we have 4 choose 2, that's for our red ones, times 10 choose 2, those are our 10 not red ones. And that comes out to 270. So, out of the 1,001 possibilities, 270 of them will have 2 red marbles, and then the other 2 are in the other 3 colors. Okay? Now 3 red. And you should kind of see this pattern. Well, the 3 red can be the 3 reds out of the 4 in the bag, and the 1 not red comes from the other 10. So now we have 4 choose 3 for our reds times 10 choose 1. And that is 40. So, of our 1,001 outcomes, we have 40 outcomes. That will be 3 red marbles, and then the 4th marble is something else. Green, yellow, or blue. And our final one is all 4. Now, before I press the button, think about this. How many ways can I reach into the bag or the bucket and pull out all 4 marbles that are red? Well, there's only one way to do that. If you reach in and pull out all 4 red marbles, there are none left in there, obviously. So the 4 that you can pull out are in your hand. That's it. So if we add all these together, 270 plus 40 plus 1, we have 311 possibilities. So out of the 1,001 total possible groups of 4, 311 of those will have 2, 3, or all 4 red marbles. Okay, and this is our final one. And of course, this is the most complex. So how many sets of 4 are there in which none are red, but at least one is green? So let's pull this apart. Always pull the problem apart and think about it actually physically happening. Since we cannot have any reds, okay, none are red, instead of 14 marbles, we're down to 10. So in a way, we're kind of pretending that the red marbles do not exist. Of course, they're in the bag, but we're talking about possibilities where they're not there. So since we cannot have red, instead of 14 marbles, we're now down to 10. So really, our total group of marbles to choose from is now down to 10. So what are our outcomes? We can have 1 green with 3 others, but none of the 3 others can be red or green. So we take care of our 1 green. We cannot have red. So the other 3 can be blue or yellow. And if you think about that for a second, that meets our condition above. Okay, at least one is green, but no red. So the other ones have to be blue or yellow. We can have 2 green with 2 others, and those 2 others can be blue or yellow. We can have 3 green with 1 other, and that 1 other can be blue or yellow. Or we can have all 4 green. So those are our possible outcomes. So we can use the 4 greens and the blue and yellow marbles for our others, which is 3 plus 3, which is 6. So you might want to pause it, look at this slide for another minute, and see how we're actually coming with our outcomes given the conditions we have at the top. Okay, let's go ahead and move forward. So here's our first one. 1 green with 3 others. But of course, those 3 others cannot be green, of course, because we already did that step. And they can't be red. So we can have yellow or blue for the other 3. So we calculate this like in this manner. So for our green, we have 4 choose 1. There are 4 green in the bag. We need 1 for this outcome, so 4 choose 1 times 6 choose 3. Because there are 6 possibilities for the other 3 marbles. We can only have blue or yellow. There are 3 of each, so a total of 6, and we need 3 of them to fill out our group of 4. So we have 4 choose 1 times 6 choose 3, which equals 4 times 20, or 80. So that's that outcome. Now our next outcome, 2 green with 2 others. And those 2 others can be blue or yellow. So you'll see the pattern develop here. So this is 4 choose 2, because now we have 2 green and 2 others. So 4 choose 2 for our green, and 6 choose 2 for our other 2, which can come from the blue or yellow. So that is 6 times 15, or 90. So that's that outcome. Our next one is 3 green with 1 other. And this pattern you should be able to tell by now. 4 choose 3, that's our greens, times 6 choose 1. And of course the other one there can be blue or yellow. And we can choose from the 6 of them. So 4 choose 3 is 4. times 6 choose 1, which is 6. So that's 4 times 6, which equals 24. And finally, our last outcome is just 4 green. Now, you should know this already. We have 4 green in the bag, and we're going to pick all 4 green. How many ways can we do that? Well, only one. So 4 choose 4 is 1. There's only one way to do that. So, to figure out the total here, or total possibilities, we just add those together. So 80 plus 90 plus 24 plus 1 is 195. Okay? So, how can we get at least 1 green but no reds? And those are our possibilities. So you just have to pick the problem apart, think about it step by step. I even tell the students I work with, I'm like, if you have to, actually I encourage them, draw pictures. If you have to draw marbles on your paper when you're first learning it, do it. I mean, I've actually had students who are very kinesthetic, very tactile, and they've actually taken like pieces of paper and wadded them up into little marble-like things. And we take those, and these are freshmen, sophomores in college. We'll wad them up into little balls, and we'll mark them, R, G, Y, or whatever. And then we'll actually put them, in a bag or on the table or something, and shake them up, and reach in and grab 4. You can actually see the actual doing, the choosing. If that's what it takes, do it. If that's what it takes, do it. All right, now we're almost done. Now, if you saw on the last slide, that was a lot of work. We had to do 4 different outcomes and then add them all together. But there's actually an easier way. But again, it's not the way we usually think. We usually think straightforward, step by step. So this is kind of the reverse way. And just follow along with me and you'll see how it works. Now here's what we know. We know that we cannot have any red marbles. So our total to choose from is 10, not 14. So we're kind of taking the reds out. So our total is 10. So all possible without red is 10 choose 4. We're just choosing 4 out of the 10 because the reds are gone. So 10 choose 4 equals 210. Now, we must have at least 1 green, so we have to have 1, 2, or 3 greens. But think about what that means. That means, sort of on the complement side, that means we cannot have 0 greens. So having 1, 2, or 3 greens, okay, or 4 greens, sorry, we cannot have 0 greens. So that, I just want to pause here to tell you, at least 1 green, so 1, 2, 3, or 4 green. I missed a 4 in there, my apologies. So what that means is we cannot have 0 green. So how would we represent 0 green? So all possible without red or green, only blue or yellow, is 6 choose 4. So let me back up for a second so you really understand where this came from. We cannot have red, we know that. Our condition says we must have at least 1 green. So 1, 2, 3, or 4 green. That means we cannot have 0 green. So if we're thinking about this in reverse, kind of, or the complement, we need to figure out what can we have that doesn't have red or green. So 0 green. We're only left with blue or yellow, which is 6. So all possible without red or green is 6 choose 4, which is 15. So if we subtract from our total, we have 10 choose 4, which was 210, minus 6 choose 4, which is what we cannot have. Okay? we come up with 195, which is the same answer we got in the previous slide. So, all this is that you walk into your house from the front door, or you can walk into your house from the back door. Either way, you end up in the same place, which is in your house. In the previous slide, we went through the front door. 1 green, 2 greens, 3 greens, or 4 greens. In this slide, we went through the back door of the house, which is the complement of the first one, which was 0 greens. So we thought about all the ways we can have these 4 marbles without red. That's 10, choose 4. And then we said, well, the thing we can't have is 0 green. So we're going to take the ones out of the 210 that are 0 greens and subtract them. Then we come up with 6, choose 4. So that's 210 minus 6, choose 4, which is 195, which is the exact same answer we got in the previous slide. Now, if this is your first time thinking about this way, I expect you to maybe be a bit confused, and that is normal, trust me. So, you might have to go back and look at the previous slide again, rewind and look at that, and then fast forward and look at this one and go back and forth a couple of times. But all we're doing is, in the first case, we're figuring out all the possibilities that we can have and then adding them up. In this slide, we're figuring out all the possibilities of 4 without red and then subtracting what we cannot have, which is all 4 that are green. I'm sorry, which are 0 green, I'm sorry. So, that's the answer to this sort of backdoor reverse method. Okay, so we are done. That is our video on combinations. And I titled this one Losing Your Marbles, and now you can see why. It kind of has a double meaning. So a couple of things. Just remember you may have to go back and watch those last couple of slides a couple of times because it's 2 different ways of finding the same answer. And a lot of problems in finite math and stats will want you to solve the second way because it's quicker. And of course, you have to think a few more steps or have to think in a different way to solve it that way. So just keep that in mind. Now, we'll be doing more examples of combination problems in my next few videos, so this is only the beginning. And then we're going to proceed into talking about assigning probabilities in combinations. So that's what's sort of coming up. Now, again, if you're having problems in a course, I want you to stay positive and keep your chin up. You're smart, you're talented, you can get through it. And I know with a little bit of help and determination and hard work, you can succeed. So just believe in yourself because I believe in you. All right? Now, we're going to go ahead and wrap it up. Again, thank you very much for watching, and I look forward to seeing you again next time.